We are very happy to have with us Leo Yu, who's the Senior Global Product Manager at JinkoSolar, and Leo will talk to us about Tiger Neo N-type solar technology for improved performance. Leo, the floor is yours.
Hi, Michael. Is that clear for you?
Yeah, we hear you loud and clear.
Okay, sure. Thank you. Okay. Hello, everyone. This is Leo from JinkoSolar product management team. And today I'm going to share the N-type technology. And after the Tiger Neo 620-watt product launch, and you might hear from a various platform that Jinko is going to produce the N-type product. Hence, we're here to share this N-type technology to give you more details introduction of the concept of the N-type technology. So this presentation will focus more on the N-type technology itself. First of all, why do we focus on the N-type? The trend of the module evolution and the development is nothing more than power clamping, which is directly linked to the efficiency of the cells. As a present, the efficiency of the PERC cells has gradually approached to its own efficiency limitation, 24.5%. In addition to upgrading the cells technology, the power breakthrough can be only achieved from the cell size and the module version, which is undoubtedly bring more greater pressure to the operation and the maintenance cost, and also matching the inverter. While the efficiency limited of the N-type TOPCon cells is much higher than the of the P-type cells. And the data widely recognized that it is 28.2% to 28.7%, which has been absolute cost performance advantage in the long terms. It can be said that the rise of N-type technology is an inevitable trend in the future. And also the timing of the transition depends on the many factors, including the market demand, the silver price, and the cell capacity expansion. At the present, the market share of the N-type module is about 5%, but expected to reach more than 30% in the next 3 to 5 years. And also according to the research among the new technology, as you can see that in the chart, the total N-type capacity in the industry will reach more than 40 gigawatt in 2022, and also will reach to approximately 80 gigawatt in 2023. At the present, the N-type cell technology mainly includes TOPCon, HGT, IBC. Among them, the TOPCon and HGT are focused more on current N-type technology route. And by the way, HGT is also called HIT, both of them are correct. As you know, Jinko is the first batch of the module manufacturers that are trying to use N-type technology. So you might hear that the name of like HOT 1.0 and HOT 2.0. And we can match HOT 1.0 with PERT technology in the picture that we use at the beginning, while 2.0 with TOPCon that we use right now. And I briefly listed the structures of those two type of N-type cells, and they are more complex than the traditional PERC cells. But we just need to focus on the red layer. In short, the TOPCon and HGT achieve power improvement through the passivation. But the difference between them is that the TOPCon through the ternary oxide layer, while the HGT through the deposition of amorphous silicon film, which leads to a difference of their perspective process, resulting in the difference of their commercial cost about 0.5 US cent per watt. And the figure mainly comes from two aspects. Firstly, The HJT as a publicity point has a simpler production process, which is incompatible with the existing production line as a cost. And the direct result in the increase of the equipment cost is about 37 to 62 million USD per gigawatt. And also N-type technology, as I mentioned about, is under the mass production right now. And it is a rapid development stage. Innovative solutions are constantly proposed in the industry. And we have been cooperating with professional sales equipment manufacturers to optimize the manufacturing process of TOPCon while improving sales efficiency. Secondly, here is a gap in the consumption of the silver pump. According to the current data, the consumption of silver pump of HJT sales is about twice of the TOPCon. And this ratio will not be leveled in the short term. So the modules are relatively a downstream product in the industrial chain. And the difference between the TOPCon and HJT, as I said, is 0.5 cent US per watt is absolutely unacceptable on a large scale. This is why Jinko is more focused on the TOPCon technology. And in my opinion, it is still premature of HJT to become commercially or widely available at 3 to 5 years. The so-called passivation in the core point of the high efficient of our N-type cells. So what is passivation? Well, you don't have to go into the academic definition of the terms. You just need to know that what is the core role of the passivation is. The PV power generation means that the majority carriers and the minority carriers pass through the cells to form a current to generate the electricity. And in the process, they produce what is known as a recombination effect in the cell, which weaken its power generation performance. This so-called passivation allowed more majority carriers turn through it, while the restraints the minority carrier pass. Finally, the recombination rate of the majority carrier and the minority carriers is declining, so that is the cell can be higher limit efficient and in other words, better performance. In terms of the specific advantage of Jinko product, first of all, in terms of the quality assurance, N-type cells power degradation can be significantly optimized compared with traditional PERC cells due to different jobbing technology. Reaching the level of the first years and the linear 0.4%. Whether from the first years or a long-term power generation, there will be more significant advantage for N-type TOPCon technology. More technical side, the LID, a loss in the boron-dropped P-type silicon solar cell efficiency is observed during the initial light sucking process. Boron oxide complex activated by the exceeded injection of the illumination was indicated the route, because since the boron oxide complex capture the bulk minority electron as a combination center. Even hydro generation cannot passivate the boron oxide complex defects totally. The N-type cells use physiolysis dropped process. No boron oxide related LID, almost no degradation by the initial illumination. And secondly, in terms of the module temperature coefficient, the Jinko 182 N-type modules can achieve an optimized temperature coefficient of -0.3% and the increase of the average power by about 0.75%. At the same time, according to the tested data provided by the R&D department, the Tiger Neo series modules operate at an average temperature of more than 1 degree centigrade lower than the P-type of the same specification. Combined, the power generation can be increased by the up 2% in a very extreme high temperature area. And besides, the bifacial factor is improved. We should be familiar with that the bifacial factors of the traditional PERC modules about the 7%, while the N-type uses the TOPCon technology has the highest bifacial factor of 85%. As shown in the figure, use P-type monofacial module of the same specification as the baseline, and the P-type modules can provide 9.45% generation gain, while N-type module can provide 11.48% generation increase. And under this premise, our Tiger Neo series modules can deliver a power generation gain about 2.03%. In addition, the lower LETID from 0.9 to 0.9 to 1.2% P-type to the 0.4% N-type and improves the LID lower than 0.5%. Also, the better temperature coefficients from 0.75 P-type to 0.70% N-type, and also higher bifacial factor from the 70% P-type to the 85% N-type, significantly optimizing the power generation capacity. Under the conventional weather and the surface reflectivity, the Jinko Tiger Neo series module can deliver an average generation gain of more than 3%. Of course, those about the theoretical analysis has also has the data support. The data shows the modules data comparison in the Haining, China, with the same specification P-type modules as a baseline. P-type bifacial modules can bring more than power gain of 9.7%, and also the Jinko N-type TOPCon modules can bring 12.7% power gain. Comprehensive capacity increase of 3%, which is constant with our theoretical analysis. And Jinko offers 72, 78 N-type modules, highest at 620 watt, with monofacial, bifacial type. The module can be used in the virus scenario. And also we offer the special size for C&I and household modules as well. Besides, you may ask, what is the real 3% even more power generation bring to the clients? And also, and how it influenced the LCOE. As we can see, power generation is the most significant factor affects the LCOE changes. And in commercial and industry aspect, the time will be 3 to 6 months fulfill ahead of the payback period. With a limited rooftop area, the higher efficiency of N-type will be more help to get at least 3% capacity. Taking 500 kilowatt C&I project as an example, the total power generation will be 5 to 7 compared with P-type in a limited rooftop area. And also we did this analysis under 200 megawatt AC power station in Mongolia, China, and use our 605 watt N-type module versus 660 watt P-type modules as a control group. What we should focus is that our Tiger Neo modules could cover more megawatt in a single tracker, which bring 1.18% BOS cost increase, and also beside taking the power gain into the consideration, the LCE data of our Tiger Neo modules is also have significant advantage, like 6%. As a present, the company is also paying a great attention to the Tiger Neo modules, and also at the stage, we can also tell you that 182, 78, and 72 modules have the advantage in the demand research and on system globally. In terms of the production capacity, there will be 10 gigawatt capacity layout in 2022. The first 5 gigawatt capacity will be in Q1, and from Q2, while another left 5 gigawatt. It can be said that the application of the N-type technology has become an very important and very, how can I say, the inevitable trend in the future. So that is all my presentation, Michael. Thank you very much.
Thanks, Leo. Very impressive how you're moving into TOPCon. That's great news. I would also recommend that if there are any questions, please answer in the chat. We have a very dense schedule, so we move ahead. Thanks again for this wonderful overview.
Okay, thank you very much. Yeah.
Thanks. So